March 1941. At the Mare Island Naval Shipyard in Vallejo, California, the dim confines of a submarine assembly area were punctuated by the hiss of a welding torch. Edward Nelson, a welder earning $11 daily, vented his mounting irritation in a well-worn notebook. "There has to be a more efficient method," he scrawled. "This is utter folly. Navy brass urges speed, yet they dismiss my proposed solution." He navigated the labyrinthine scaffolding beneath the hull of a submarine under construction, a sight that fueled his indignation. A dozen men had dedicated an entire shift to fitting a single section of deck plating. Massive scaffolding filled the interior compartments below each wooden deck, where workers with wrenches toiled in cramped quarters, tightening nuts onto bolts that penetrated from above. Countless hours were expended solely to secure wooden planks to steel frameworks. This conventional approach demanded meticulousness, forbearance, and invaluable time America could ill afford as war clouds gathered over the Pacific. Yet, in what was rapidly becoming one of the world's most active shipyards, the methods for attachment remained unchanged for decades. Theodore Edward Nelson, 36 years old and a California native, had acquired his mechanical acumen through rigorous experience. 15 years spent in machine shops across California had taught him how metal behaved, how electrical currents flowed, and how challenges could be overcome if only he found receptive ears. The Navy supervisors were unaware that this frustrated welder had already conceived a resolution. And Nelson himself did not yet comprehend that his simple, rebuffed solution would ultimately save the United States Navy over 50 million man-hours and fundamentally revolutionize naval shipbuilding. This transformation had commenced weeks prior within the confined spaces below decks, where the true battle against inefficiency raged daily. The date was the 15th of March, 1941. 8 months and 22 days before the attack on Pearl Harbor, the Mare Island Naval Shipyard spanned 635 acres along the Napa River in Vallejo, California, 25 miles northeast of San Francisco. Established in 1854 by Commander David Glasgow Farragut, it was the inaugural United States Navy installation on the Pacific Ocean. By early 1941, Mare Island had evolved into the preeminent West Coast submarine construction facility. The yard operated continuously, with 3 worker shifts daily, 7 days a week. Submarine production had surged dramatically as tensions with Japan escalated. The yard employed approximately 12,000 civilian workers in early 1941, a figure that would balloon to nearly 50,000 by 1944. Among those 12,000 was Ted Nelson, employee number 3,872. He earned $11 per day, working the morning shift from 7 a.m. to 4 p.m. His specialty was welding, primarily on submarine hulls and internal structures. He excelled at his craft, working with speed and precision, but grew increasingly exasperated by what he perceived as egregious waste and inefficiency. The problem was pervasive. Wooden deck planking installation occurred on submarines, destroyers, and aircraft carriers alike. The Navy specified wooden decks for several critical reasons. Wood offered superior traction compared to steel in damp conditions. It provided a quieter surface for crew movement. Wood offered some insulation against the cold steel beneath, and, in the event of fire, wooden decks were more readily repaired or replaced than welded steel plates. However, the installation method was antiquated, labor-intensive, and agonizingly slow. The standard procedure, unchanged since the First World War, involved a series of intricate steps. Initially, workers would meticulously drill holes through the wooden planks at precisely marked intervals. These holes were countersunk to ensure the heads of the attachment bolts lay flush with the deck surface. Next, workers would position the planks atop the steel deck framework. Then came the ordeal. Laborers had to erect extensive scaffolding beneath the deck within the submarine or ship compartments. Multiple levels of platforms were necessary to grant workers access to the underside of the steel deck framework. Once the scaffolding was erected, workers above and below would coordinate to lower long-threaded bolts through the wooden planks and corresponding holes in the steel framework. Those below, standing on scaffolding platforms in dark, confined spaces, would thread nuts onto the protruding bolt ends. They would then tighten these nuts with wrenches, drawing the wooden planks tightly against the steel framework above. Finally, workers on the deck surface would seal the countersunk holes with wooden plugs, creating a smooth walking surface. This entire process was repeated for every decking section. A submarine might feature several hundred square feet of wooden decking, necessitating thousands of individual attachment points. On an aircraft carrier, the wooden flight deck covered tens of thousands of square feet. The labor demands were monumental. A typical submarine deck installation required a crew of 12 to 16 men working for 5 to 7 days. The scaffolding alone took 2 full days to construct and another day to dismantle. The actual bolt installation consumed the remaining time. Ted Nelson had performed this task countless times. He had spent innumerable hours balancing on scaffolding platforms, threading nuts onto bolts within cramped submarine compartments barely 4 feet high. His back ached from constant stooping. His knuckles bore scars from slipping wrenches. His patience had worn thin, but his vexation stemmed from more than personal discomfort. He grasped the broader implications. War was imminent. Everyone at Mare Island understood this. The yard was already falling behind schedule on submarine construction. The Navy urgently needed vessels operational, not languishing in dry dock awaiting deck installation. Each day of delay brought the nation closer to conflict. America was unprepared for war, and Nelson knew a better way existed. He had pondered the problem for months, mulling it over during the long hours of routine welding. The solution seemed self-evident. Instead of bolting from above and threading nuts from below, why not weld attachment studs directly to the steel framework? Weld from one side only, from the top. No scaffolding, no nuts and bolts, no workers confined to compartments below. Just swift, robust, permanent welds. The concept was straightforward. A threaded stud, essentially a headless bolt, could be fused to the steel deck framework in a fraction of a second. The wooden planks would be equipped with threaded inserts or specialized nuts to engage these studs. The entire operation could be completed from the top side exclusively. No scaffolding, no work below deck, no need for coordination between crews above and below. Nelson had previously encountered stud welding in a limited capacity. The technology existed for horizontal flat plate welding. A small quantity of flux powder would be placed on a flat steel surface. A stud would be positioned in the flux. An electrical arc would fuse the stud to the steel. However, this method was effective only on horizontal, flat surfaces. The flux powder would simply dislodge from vertical or overhead surfaces, and naval construction demanded welding in all orientations: vertical, horizontal, overhead, and at all angles. This had been a perplexing issue for welding engineers for 2 decades. How to adapt stud welding for non-horizontal applications? Nelson believed he had found the answer. It was so simple that he almost laughed when the solution occurred to him. Instead of loose flux powder, encase the flux within a small ceramic sleeve. Attach the sleeve to the stud's end. The flux would remain in place regardless of orientation. He sketched his concept in his notebook. A handheld welding gun, a spring-loaded mechanism to press the stud against the steel surface, an electrical trigger to initiate the welding arc, and a disposable ceramic flux sleeve on the end of each stud. The entire process would take less than 1 second per stud. A single worker could install dozens of studs in the time it currently took to secure a single bolted connection. He presented his idea to his supervisor, a Navy lieutenant named Morrison. The meeting lasted less than 5 minutes. Morrison barely glanced at the sketches. "We have established procedures, Mr. Nelson. We adhere to Navy specifications." Nelson tried again, approaching the shipyard's chief welding engineer, a civilian contractor named Hartwell. He detailed the time savings, the reduction in labor, and the elimination of scaffolding expenses. Hartwell was more courteous than Morrison, but equally dismissive. "Son, individuals far more astute than you and I have grappled with this challenge for 2 decades. If it were that straightforward, someone would have achieved it already. Furthermore, the Navy has specifications. We cannot simply alter procedures based on a welder's notion. You require approval from the Bureau of Ships in Washington. Engineering studies are mandatory. Prototypes must be tested. That process consumes years. We do not have years," Nelson countered. "We require submarines now." Hartwell shrugged. "That is not my concern, Mr. Nelson. My concern is constructing vessels in accordance with approved specifications. Your concern is performing the welding work for which you are compensated." Nelson departed the meeting feeling angry and disillusioned. He had offered a solution capable of saving thousands of hours per submarine. They had dismissed him without serious consideration, not due to any flaw in his concept or its feasibility, but because he was merely a welder. Because procedural changes necessitated paperwork and approvals. Because innovation was secondary to adhering to established protocols. He made one final attempt, dispatching a formal letter to the shipyard commander, Captain Thomas Withers. The letter was meticulously crafted, outlining the current inefficiencies, proposing the stud welding solution, and estimating time and cost savings. He submitted the letter through the proper channels, following the established procedure for worker suggestions. 3 weeks later, he received a reply, a form letter thanking him for his interest in enhancing shipyard efficiency, a polite explanation that all technical proposals were assessed by the Bureau of Ships Engineering Review Board. It noted that his suggestion had been forwarded for consideration, with a realistic assessment that the review process typically lasted 18 to 24 months. He would be notified if his proposal was advanced for further study. 18 to 24 months. By then, the war might have concluded or been lost. Nelson crumpled the letter and discarded it in a waste receptacle. That evening, he made a decision that would irrevocably alter his life and the trajectory of naval history. If the Navy refused to listen, he would build it himself. He would demonstrate the efficacy of his concept. Then, they would be compelled to pay heed. He cleared a space in the garage behind his modest cottage in Vallejo. His wife, Emma, watched with apprehension as he began gathering scrap steel and welding apparatus. "Ted, you'll get yourself fired," she cautioned. "You're supposed to be working on Navy projects, not your own inventions." "This will benefit the Navy," he responded. "They simply aren't aware of it yet." Over the ensuing weeks, dedicating his evenings and weekends, Nelson constructed his inaugural stud welding gun prototype. The design was rudimentary, yet functional. A pistol grip handle, a spring-loaded plunger to hold and press the stud, an electrical trigger connected to a welding power supply, and a quick-release mechanism for loading new studs. The most crucial innovation was the flux sleeve. He experimented with various ceramic materials, different flux compositions, and diverse sleeve designs. After dozens of trials, he developed a sleeve that securely contained the flux, facilitated proper arc initiation, and could be manufactured affordably. By May 1941, he possessed a working prototype. He tested it on scrap steel in every conceivable position: horizontal, vertical, overhead, and at angles. The gun performed flawlessly. A stud could be welded in less than 1 second. The weld strength surpassed that of traditional through bolts, and most importantly, it eliminated the need for undersurface access. He brought the prototype to work, demonstrating it to several fellow welders during their lunch break. They were impressed and enthusiastic. "This is going to save us so much time," one remarked. "You need to show this to Morrison," another suggested. Nelson shook his head. "I already showed Morrison. He wasn't interested." "Then quit and start your own company," a third welder advised. Sell your gun to shipyards across the country. You'll make a fortune. The idea had not previously occurred to Nelson. He was a welder, not a businessman. He lacked capital, a manufacturing facility, and business experience. However, the more he considered it, the more logical it seemed. If the Navy wouldn't adopt his invention, perhaps private shipyards would. The Kaiser shipyards in Richmond were hiring. The Bethlehem Steel Shipyard in San Francisco was expanding. Shipyards lined the entire West Coast, all facing similar labor shortages and production pressures. On June 20th, 1941, Ted Nelson submitted his resignation from the Mare Island Naval Shipyard. His supervisor attempted to dissuade him. "Nelson, you're a skilled welder. Don't squander a stable position for some fanciful invention." But Nelson's resolve was firm. "I'm going to build welding guns," he told Morrison. "And when the Navy returns seeking to purchase them, I hope you'll recall this conversation." He departed Mare Island with $11 in his pocket, a garage filled with tools, and an unshakable conviction in his invention's success. He officially incorporated the Nelson Specialty Welding Equipment Corporation on July 1st, 1941. He secured a loan of $95,000 from the Reconstruction Finance Corporation, a government lending institution established during the Depression to support small businesses. With this capital, he leased a small workshop in Vallejo and began manufacturing stud welding guns. The initial months were arduous. He had no customers, no reputation, and no distribution network. He made sales calls to local machine shops and small fabrication companies, demonstrating his gun and explaining its time-saving benefits. Most were skeptical. A few expressed sufficient interest to trial a demonstration unit. Gradually, very gradually, orders began to materialize. By September 1941, he had sold 18 welding guns and several thousand flux-sleeved studs. Then, on December 7, 1941, everything changed. Pearl Harbor. The Japanese attack devastated or damaged 8 battleships, 3 cruisers, 3 destroyers, and 188 aircraft. 2,403 Americans perished. The United States was at war. Suddenly, shipbuilding was not merely important. It was a matter of national survival. Within days of Pearl Harbor, the shipbuilding industry erupted into frenetic activity. The Kaiser shipyards commenced building Liberty ships at an unprecedented rate. The Mare Island Naval Shipyard received emergency orders for submarine construction. Bethlehem Steel and other private yards began operating triple shifts, and every single one of these facilities confronted the same challenge: how to build ships quickly enough. The traditional methods were too slow, too labor-intensive, and too wasteful of precious time. Ted Nelson's telephone began to ring. Shipyard purchasing agents who had dismissed his invention weeks earlier now sought to place substantial orders. The Kaiser shipyards ordered 50 welding guns and 10,000 studs. Bethlehem Steel ordered 40 guns. Even the Mare Island Naval Shipyard, where he had been rebuffed mere months prior, placed an order for 60 guns and 20,000 studs. Morrison, his former supervisor, handled the purchase requisition. There was no apology, no acknowledgement of Nelson's correctness, merely an official order and a request for prompt delivery. By January 1942, less than 1 month after Pearl Harbor, Nelson's modest workshop could not meet the demand. He was receiving orders faster than he could manufacture products. He required a proper factory, additional personnel, and improved equipment. He leased a larger facility in San Leandro, a few miles south of Oakland. The building stood amidst a cornfield, isolated and unimpressive, but it offered space, power, and room for expansion. By March 1942, he employed 20 workers. By June, 50. By September, 150. The factory operated around the clock, 7 days a week. Welding guns rolled off the assembly line at a rate of 30 per day. Stud production reached thousands per day. Every major shipyard on the West Coast was now utilizing Nelson stud welding equipment, and the reports emanating back were extraordinary. A submarine deck installation that previously necessitated 12 workers and 6 days could now be completed by 3 workers in a single day. The elimination of scaffolding saved an additional 2 days and freed up personnel for other tasks. The welds were stronger than conventional bolted connections. The wooden deck planks could be removed and replaced more easily for maintenance or repair. At the Mare Island Naval Shipyard, submarine construction accelerated dramatically. The yard completed 17 submarines between 1941 and 1945, with an average construction time that steadily decreased as new techniques were implemented. Stud welding was not the sole innovation, but it was a crucial element of the efficiency equation. By mid-1942, stud welding was being employed not just for deck attachments, but for dozens of other applications: pipe hangers, cable supports, equipment mounts, and bulkhead attachments. In any situation where a fastener needed to be affixed to a steel structure, stud welding offered a swifter solution. The Navy's Bureau of Ships, which had initially disregarded Nelson's proposal, now meticulously studied his process. Engineering teams analyzed weld strength, durability, and failure modes. The results corroborated what Nelson had always known. His welds were not merely faster than traditional methods. They were, in fact, superior in strength and reliability. On November 19, 1942, just 11 months after leaving his $11 a day welding position, Ted Nelson received a formal visit from a delegation of Navy officers. They arrived at his San Leandro plant unannounced. A group of 5 men in dress uniforms. Captain Harrison, representing the Bureau of Ships, addressed him. "Mr. Nelson, we are here to inform you that the Navy has concluded its evaluation of your stud welding process. We have determined that your invention has saved the United States Navy an estimated 5 million man-hours in submarine and surface ship construction over the past 10 months. This figure is projected to increase substantially as more shipyards adopt your technology." He paused, then continued. "On behalf of the Secretary of the Navy and the United States government, I am authorized to present you with a citation for exceptional contribution to the war effort." Nelson was stunned. They had rejected his idea. They had ignored his proposals. They had forced him to leave his job and risk everything to prove his concept. And now, they were bestowing a citation upon him. Captain Harrison must have perceived the conflict on Nelson's face. "I understand you submitted a proposal to Mare Island in early 1941, Mr. Nelson. I have reviewed that file. Your proposal was not properly evaluated at the time. That was an error, and I apologize on behalf of the Navy. However, your decision to develop the technology independently has resulted in a faster deployment than would have been possible through the standard procurement process. Sometimes, the most effective way to serve your country is to disregard official channels and simply solve the problem." Nelson accepted the citation with a mixture of emotions: pride in his accomplishment, vindication for his perseverance, but also frustration at the bureaucratic inertia that had nearly prevented this innovation from materializing. The war continued. Production demands escalated. Nelson's company expanded again, opening a second manufacturing facility in Camden, New Jersey, in March 1943. This manufacturing facility on the East Coast was a vital supplier to shipyards in prominent locations such as New York, Philadelphia, Norfolk, and Charleston. By the middle of 1943, the Nelson enterprise had grown to employ over 400 individuals and was generating annual revenue in the vicinity of $4 million. Ted Nelson himself continued to dedicate 16 hours each day to the factory floor, adhering to his customary attire of tan work pants and shirts. His personal remuneration remained a modest $1,000 per month. All profits were meticulously channeled back into the company for reinvestment in expansion initiatives, acquiring new equipment, and servicing outstanding loan obligations. Nevertheless, his contribution to the war effort was immeasurable. The Navy's conservative estimate of 5 million man-hours preserved by the end of 1942 was merely the initial indication of his impact. As the conflict intensified and the adoption of stud welding became a standard procedure across all naval shipbuilding, the accrued time savings escalated exponentially. By 1943, stud welding was being utilized not solely on submarines, but also on aircraft carriers, battleships, cruisers, destroyers, and a multitude of smaller naval craft. The highly regarded Essex-class aircraft carriers, constructed by Newport News Shipbuilding and other shipyards, incorporated Nelson stud welding extensively for the crucial task of attaching flight decks and for various interior fixtures. Each of these carriers required an estimated 20,000 studs. Throughout the war, the Navy commissioned 24 Essex-class carriers. The formidable Iowa-class battleships employed stud welding for the installation of deck planking, the secure mounting of equipment, and the attachment of armor plating. The Baltimore-class heavy cruisers integrated this innovative technology throughout their construction. Destroyer escorts, landing ships, patrol boats. Indeed, every category of naval vessel benefited from these accelerated and more robust fastening methods. However, the most profound impact was observed in submarine construction. The Mare Island Naval Shipyard, where Nelson had previously worked and where his groundbreaking idea had initially been met with resistance, subsequently emerged as one of the world's most efficient submarine builders. This facility successfully constructed 17 submarines during the war, consistently improving its construction timelines. The Portsmouth Naval Shipyard in New Hampshire distinguished itself as the preeminent submarine builder, completing 79 submarines between July 1940 and July 1945. Portsmouth's remarkable success was a culmination of numerous advancements, with stud welding playing a pivotal role as an enabling technology. The shipyard enthusiastically adopted Nelson's system, deploying it not only for decking, but throughout the interior of the submarines. The tangible results of this adoption were readily apparent in construction statistics. On January 27, 1944, Portsmouth proudly launched 3 submarines simultaneously: the Redfish, the Ronquil, and the Razorback. A 4th submarine, the Scabbardfish, was also launched on that same day. The achievement of launching 4 submarines in a single day was unprecedented and remains unmatched in shipbuilding history. During the peak of its production, Portsmouth completed 32 submarines in 1944, averaging approximately 1 submarine every 11 days. The Ballow-class submarines, which constituted the majority of wartime production, took an average of 12 months from keel laying to commissioning at Portsmouth. This time frame was several months shorter than that of other shipyards constructing the same class of vessel. The Electric Boat Company in Groton, Connecticut, produced 74 submarines during the war. Mantorock Shipbuilding in Wisconsin, despite its inland location on the Great Lakes, hundreds of miles from the ocean, successfully built 28 submarines that were subsequently floated down the Mississippi River to the Gulf of Mexico. Collectively, across all yards, the United States delivered 203 submarines during the Second World War. Each submarine necessitated thousands of stud-welded attachments. Each individual stud accounted for savings of minutes in labor. When these minutes were multiplied by thousands of studs per submarine, and then by hundreds of submarines, the cumulative time savings reached astonishing proportions. Yet, submarines represented only a fraction of the overall narrative. The true volume of production lay in surface vessels and merchant ships. The Liberty Ship program, overseen by the Maritime Commission and primarily built at Kaiser shipyards, yielded a remarkable 2,710 cargo ships during the war. Each Liberty ship required approximately 5,000 to 8,000 stud-welded attachments for tasks such as deck planking, the installation of cargo handling equipment, defensive gun mounts, and general ship fittings. The Victory ships, a more advanced and faster design, were constructed to comparable standards. The sheer scale of this production was unparalleled in human history. At the zenith of Liberty ship construction in 1943, American shipyards launched 3 new vessels daily, amounting to 75 ships per month, or 900 ships annually. This extraordinary output was made possible by radical innovations in construction methodologies, including prefabrication, modular assembly, the deployment of specialized labor, dedicated tooling, and accelerated attachment techniques. Stud welding, while a single component, was an indispensable element of this broader revolution in shipbuilding efficiency. The elimination of scaffolding liberated workers to engage in other critical tasks. The speed of installation dramatically reduced assembly durations. The inherent strength and reliability of these welds ensured that these rapidly constructed ships could withstand the harsh conditions of North Atlantic storms and evade enemy attacks. By the spring of 1943, the United States Navy formally acknowledged Nelson's pivotal contribution. On May 11, 1943, the Secretary of the Navy bestowed upon the Nelson Specialty Welding Equipment Corporation the prestigious Army-Navy E Award for Excellence in Production. This esteemed E Award, established in July 1942, was instituted to recognize companies that demonstrated outstanding performance in the manufacturing of war materiel. Excellence in both quality and quantity were the definitive criteria for selection. A mere 5% of companies engaged in wartime production were privileged to receive this distinguished honor. The award comprised a pennant for the factory and individual pins for all employees. The presentation ceremony took place at the San Leandro plant, complete with full military honors. Navy officers, Army representatives, and local dignitaries were in attendance. The factory workers, Nelson's dedicated employees, who had endured grueling hours to meet production quotas, accepted their pins with profound pride. Ted Nelson, standing before his team in his characteristic work attire, accepted the pennant and delivered a concise address. He stated, "We did not undertake this for awards or recognition. We did this because our nation required it. Every stud we produce, every gun we build, contributes to bringing our sailors and soldiers home safely. That is the sole reward we require." The Navy, however, was not yet finished acknowledging Nelson's remarkable achievements. Facilities that sustained exceptional performance for a period of 6 months following their initial E Award were granted a star to be affixed to their pennant. The Nelson Company earned its inaugural star in November 1943, followed by its second star in May 1944. By the conclusion of the war, the Nelson Specialty Welding Equipment Corporation had received 2 E Awards, accompanied by stars, placing it among a select group of companies to achieve such a notable distinction. The official citations specifically highlighted the estimated 50 million man-hours saved in naval construction. 50 million man-hours. Let that figure resonate. 50 million hours is equivalent to approximately 5,700 years. If a single individual were to work 8 hours per day, every single day, it would take in excess of 19,000 years to accumulate 50 million hours. This significant time saving was the direct outcome of one elegantly simple innovation: a spring-loaded welding gun and a ceramic flux collar. The time efficiencies realized translated directly into a more rapid deployment of ships into active service. This meant more submarines actively hunting Japanese convoys, more destroyers escorting vital convoys, more aircraft carriers launching decisive strikes, and more landing ships delivering Marines to perilous enemy shores. Each vessel delivered sooner meant augmented combat power, more supplies reaching their destinations, and ultimately, more lives preserved. The strategic ramifications of this were immeasurable. However, Nelson's invention yielded an additional, unforeseen benefit. The stud welding process demanded considerably less specialized skill compared to traditional bolting methods or conventional welding techniques. With minimal instruction, new employees could competently and safely perform stud welding operations. This was a critical advantage as the war progressed and labor shortages became increasingly acute. Women began entering shipyards in unprecedented numbers. The iconic figure of Rosie the Riveter symbolized female shipyard workers, but there were also individuals like Wendy the Welder. Women expertly operated stud welding guns, installed deck planking, and mounted vital equipment. Many achieved a high degree of proficiency in the process. At its peak, the Mare Island Naval Shipyard employed nearly 50,000 workers, including 9,000 women. Kaiser shipyards, in turn, engaged hundreds of thousands of employees, with women comprising nearly 30% of the workforce. These women required tools and procedures that were both easily learned and inherently safe to operate. Stud welding perfectly fulfilled these essential requirements. By 1944, the momentum of the war had definitively shifted in favor of the Allied forces. American industrial production had decisively surpassed the capabilities of the Axis powers. The United States manufactured more ships, aircraft, tanks, and armaments than Germany and Japan combined. The arsenal of democracy, as President Roosevelt eloquently termed it, operated at its maximum capacity. Ted Nelson's stud welding guns represented a small but vital component of this colossal industrial accomplishment. However, even small components play a significant role. In wartime, efficiency is measured in lives safeguarded and battles decisively won. Accelerated ship construction facilitated the earlier deployment of naval forces. Enhanced naval power translated into the sinking of more Japanese shipping, the capture of more strategic islands, and increased pressure on the enemy. The submarine campaign in the Pacific vividly illustrated this principle. American submarines sank over 1,000 Japanese merchant vessels, totaling approximately 5 million tons. They also accounted for the destruction of 1 aircraft carrier, 8 battleships, and numerous cruisers and destroyers. This success was rendered possible solely by America's ability to produce submarines at a rate faster than Japan could replace its losses. Japan had initiated the war with a larger submarine fleet than the United States. However, Japan managed to build only 126 submarines during the entire conflict. In contrast, America constructed 203. Every month of accelerated production was consequential. Each week, a submarine reached the fleet sooner meant an additional week available for actively hunting enemy shipping. The Essex-class aircraft carrier program exhibited similar trends. The United States Navy possessed 7 aircraft carriers in December 1941. By August 1945, the Navy commanded a fleet of 99 aircraft carriers of all types. The Essex-class fleet carriers formed the core of this formidable force. 24 of these vessels were completed, each capable of carrying up to 90 aircraft. The swift carrier task forces, built around the Essex-class carriers, dominated the Pacific theater from mid-1943 onwards. These powerful ships bombarded Japanese positions, launched devastating airstrikes, provided essential air cover for amphibious landings, and engaged Japanese naval forces in pivotal battles. The Battle of the Philippine Sea in June 1944 witnessed American carrier aircraft decimate over 600 Japanese planes in an engagement that pilots famously dubbed the Great Marianas Turkey Shoot. This resounding victory was achievable only because America had a superior number of carriers strategically positioned at the opportune moment. Accelerated construction directly enabled faster deployment. The D-Day invasion of Normandy on June 6, 1944, necessitated the deployment of 7,000 ships and landing craft. This immense armada, the largest amphibious assault in history, was only feasible due to the rapid construction of landing craft by American and British shipyards, numbering in the thousands. These landing ships were rudimentary vessels, essentially flat-bottomed boats designed to beach themselves and offload their cargo. However, their construction demanded speed and reliable fittings. Stud welding proved exceptionally well suited for landing craft construction. Cargo ramps, davit mounts, and deck fittings could all be installed with remarkable speed and security. The technology that Nelson had initially developed for attaching studs to submarine decks found widespread application throughout the landing craft fleet. Following victory in Europe Day in May 1945, attention fully shifted to the Pacific theater. The planned invasion of Japan, codenamed Operation Downfall, was scheduled for November 1945. This ambitious operation would require a greater number of ships, landing craft, and logistical support than any preceding campaign. Shipyards prepared for another surge in production. Then, on August 6th and 9th, 1945, atomic bombs devastated Hiroshima and Nagasaki, leading to Japan's surrender. On August 15th, 1945, the Second World War officially concluded. The colossal military production apparatus began a gradual deceleration. Contracts were rescinded, workers were laid off, shipyards ceased operations or transitioned to civilian production. The Nelson enterprise faced an uncertain future as military orders evaporated almost overnight. The company, which at its peak had employed over 400 workers, now confronted the potential of collapse. However, Ted Nelson had anticipated this scenario. Throughout the war years, he had actively contemplated peacetime applications for stud welding. The inherent capabilities of the technology were not confined to shipbuilding. Any industry involved in the fabrication of steel structures could potentially benefit from more efficient attachment methods. This included sectors such as construction, bridges, buildings, tanks, and automotive manufacturing. The scope of possibilities was extensive. Nelson strategically pivoted towards civilian markets. He actively marketed his stud welding systems to construction firms, steel fabricators, and industrial manufacturers. The post-war construction boom presented abundant new opportunities. America was engaged in extensive projects involving highways, bridges, skyscrapers, and suburban development, all of which required substantial steel fabrication and attachment. By 1948, Nelson's company had successfully navigated its transition to peacetime production. While smaller than its wartime scale, the business was stable and experiencing growth. The company continued its tradition of innovation, developing novel stud designs, enhanced welding guns, and specialized application solutions. In 1950, Nelson divested his company to TRW, a major industrial conglomerate. This transaction secured Nelson's financial future and permitted him to retire from active operational management. Importantly, the Nelson name remained prominently associated with the product line. TRW continued to market Nelson's stud welding equipment, effectively preserving the brand recognition that Nelson had meticulously cultivated. Over the subsequent decades, the company underwent several ownership changes. TRW sold its interest to Farsantech Incorporated in the year 2000. Doncasters Group Limited acquired Fentech in 2007. Stanley Black & Decker purchased the industrial division in 2018. Throughout these transitions, the Nelson brand persisted. Today, Stanley Engineered Fastening manufactures and distributes Nelson stud welding products on a global scale. The technology that Ted Nelson pioneered in his garage in Vallejo continues to be utilized worldwide. Modern stud welding systems incorporate advanced features such as inverter power supplies for precise arc control and automated systems designed for high-volume production. Robotic welders now apply studs in automotive assembly plants, yet the fundamental principle remains remarkably consistent. A stud, a flux collar, a spring-loaded gun, and an electrical arc. 1 second per stud. No scaffolding is required. The applications have expanded far beyond their origins in shipbuilding. Construction professionals employ stud welding to attach metal decking to steel beams in skyscrapers. Bridge builders utilize it for installing guardrail posts and lighting fixtures. Nuclear power plants rely on it for securing cable trays and supporting vital equipment. Automotive manufacturers integrate it throughout vehicle bodies for grounding points and trim attachment. The technology that Nelson invented to address a specific naval construction challenge has found pervasive applications in virtually every industry that works with steel. However, perhaps the most poignant testament to Nelson's invention lies in the restoration of historic vessels. The battleship Texas, one of the rare surviving ships to have participated in both world wars, is presently undergoing extensive restoration at a dry dock facility. The vessel requires substantial work to repair corroded hull plates and deteriorated fittings. The restoration team discovered that modern Nelson stud welding equipment is ideally suited for this undertaking. They are able to attach new steel plates utilizing the very same technology that Ted Nelson devised 80 years prior. Similarly, the submarine USS Pampanito, a World War II veteran now preserved in San Francisco, employs Nelson stud welding for its ongoing maintenance. Moored at the Embarcadero, the submarine attracts over 100,000 visitors annually. Maintaining the safety and operational integrity of this historic vessel demands continuous attention. Nelson equipment enables the volunteer restoration crew to perform welding tasks efficiently, without the necessity of employing certified welders for every operation. Ted Nelson lived to witness his invention's impact extend far beyond his initial imaginings that day in 1941, when he first sketched his concept in a notebook. He saw stud welding become the standard methodology in shipbuilding. He observed its adoption across industries globally. He witnessed his name become synonymous with a revolutionary welding process. He passed away in 1994 at the age of 89, having lived long enough to experience the end of the Cold War and the profound transformation of the world his generation had fought so valiantly to preserve. The statistics quantifying his achievements only tell a partial story. 50 million man-hours saved, 2 Army-Navy E awards received, thousands of ships constructed more rapidly, and billions of studs manufactured. However, these numbers alone cannot fully encapsulate the complete impact. Behind these impressive figures were sailors who returned home because their submarine was completed in time to join the fleet. Marines who survived their assaults because landing craft were readily available. Families who remained intact because the war concluded sooner. The ultimate measure of innovation transcends mere efficiency gains. It lies in the preservation of lives. Ted Nelson, the humble welder earning $11 a day, who was initially told his concept was impractical, ultimately saved more lives than many decorated combat heroes. He achieved this not through instruments of destruction, but through the constructive force of welding, not by causing devastation, but by facilitating creation. The rejection he encountered was far from unique. History is replete with innovators who were initially dismissed by established authorities. Wilbur and Orville Wright were told that powered flight was an impossibility by purported experts. Henry Ford faced ridicule for proposing that automobiles could be mass-produced. Chester Carlson spent years attempting to market his groundbreaking xerography process before finding a receptive buyer. What distinguished Nelson was his unwavering refusal to accept rejection. He did not engage in debates with bureaucrats. He did not squander valuable time attempting to persuade skeptics. Instead, he resigned from his position, risked his personal savings, and empirically demonstrated the efficacy of his concept. Subsequently, the marketplace itself served as the most compelling advocate for his invention. This represents the very essence of American ingenuity, not waiting for official sanction, not adhering rigidly to established protocols, and certainly not accepting the premise that tasks must perpetually be performed in accordance with historical precedent. It involves identifying a problem, developing a viable solution, and possessing the courage to implement it, irrespective of institutional resistance. The Mare Island Naval Shipyard, where Nelson had once been employed and where his revolutionary idea had been initially rejected, ceased operations in 1996 after a distinguished service of 142 years. Throughout its existence, the shipyard was responsible for constructing 512 ships and undertaking repairs on thousands more. The facility played a crucial role in the construction of 44 submarines, including the last nuclear submarine built in California, the USS Drum, launched in 1970. The base was designated a California Historical Landmark in 1960, and specific sections were recognized as a National Historic Landmark District in 1975. Today, the former shipyard is undergoing redevelopment as a commercial and residential hub. Some of its historic structures have been preserved, including the chapel, dry docks, and various industrial buildings. As visitors walk through these preserved spaces, they can vividly imagine the intense activity of the war years when tens of thousands of workers toiled around the clock to build submarines. In Building 46, the former pipe shop that remained operational until 1984, a small museum now resides. Among its exhibits are tools, photographs, and artifacts chronicling the shipyard's rich history. Notably, there is no dedicated exhibit specifically honoring Ted Nelson. There is no monument to the welder credited with saving 50 million man-hours. His remarkable story remains largely obscure, known primarily within the circles of welding professionals and maritime historians. This anonymity would likely not have caused Ted Nelson any distress. He was not seeking personal fame or public accolades. His driving motivation was to resolve a problem, to enhance efficiency, and to contribute meaningfully to his country's victory in the war. The fact that his solution proved effective, that it conserved valuable time and saved lives, and that it fundamentally transformed an industry, these were in themselves ample rewards. Nevertheless, a crucial lesson for every generation resides within his narrative. True innovation frequently emerges from unexpected origins. It does not always stem from credentialed experts, but often from diligent working individuals who confront daily challenges and possess an intrinsic understanding of how to overcome them. It does not exclusively originate from corporate research laboratories, but from humble garage workshops where persistent tinkers experiment tirelessly until they achieve breakthroughs. It does not always follow official channels, but frequently arises from individuals willing to stake everything on a concept they intuitively believe in. The next groundbreaking innovation could originate from a welder in a shipyard, a mechanic in a garage, a nurse in a hospital, or a teacher in a classroom. It might emerge from someone whom official channels dismiss as unqualified, someone whom bureaucrats instruct to adhere strictly to established procedures, or someone whom experts assure is squandering their time on an intractable problem. Historical evidence strongly suggests that we ought to pay close attention to these individuals. Not every idea they present will prove viable, but on occasion, a single idea that does succeed can precipitate a profound and widespread transformation. Ted Nelson's ceramic flux collar, a seemingly simple component, represented a small piece of ceramic that, when combined with his ingenuity, ignited a revolution. His stud welding apparatus, though merely a basic spring-activated mechanism, when utilized in conjunction, eliminated the need for external frameworks, expedited workflows, enhanced workplace safety, elevated construction standards, and accelerated the production of naval vessels during a crucial historical juncture. 50 million man-hours, amounting to 5,700 years, is the staggering sum of labor ultimately conserved by one welder's initially disregarded concept. And this figure represents solely the direct savings in assembly duration. It does not encompass the strategic advantage of more rapid ship deployment. It fails to quantify the lives preserved due to submarines reaching the Pacific theater sooner. It does not compute the morale surge derived from surpassing production targets. It omits the chilling effect on adversaries of American naval might expanding at a pace exceeding their projections. While the complete magnitude of Ted Nelson's innovation may elude precise calculation, it is undeniable that America's triumph in the Second World War hinged as much on its industrial prowess as on the bravery of its armed forces. The engagements were secured by soldiers, mariners, and ground troops. However, the conflict itself was ultimately won by the collective efforts of laborers, engineers, and forward thinkers. Individuals like Ted Nelson, who identified an issue and devised a resolution, who rejected the notion of tolerating inefficiency when superior methods were attainable, who grasped that in total conflict, every moment reclaimed in manufacturing translated directly to lives safeguarded on the battlefield. As we confront the trials of the 21st century, this enduring lesson remains pertinent. The formidable challenges we face, including atmospheric shifts, dwindling natural resources, and deteriorating infrastructure, necessitate ingenuity at all echelons. Solutions will emerge not exclusively from prestigious academic institutions and corporate research facilities, but from working individuals who perceive problems with clarity and develop practical remedies. The subsequent Ted Nelson might be conceptualizing an improved solar energy collector within a home workshop. The next significant advancement could originate from a factory operative who possesses an exact understanding of what impedes progress and squanders resources. The forthcoming revolution in operational effectiveness might be initiated by someone previously deemed unqualified through official channels. We must be receptive. We must foster inventive thinking from every avenue. We must diminish the obstacles separating the identification of issues from the execution of their solutions. We must recall that some of history's most impactful inventions arose from individuals operating outside established structures, precisely because those structures were disinclined to listen. Ted Nelson commenced his career as a welder, earning $11 per diem. He concluded it as a prosperous industrialist whose technological contributions were instrumental in his nation's victory. Yet, he never disavowed his origins. He never adopted airs of superiority. He never presented himself as anything beyond a skilled tradesperson who recognized a problem and rectified it. In his later years, when queried about his achievements, he would simply remark with a shrug, "I merely engineered a superior vermin trap. The world then sought me out." It was not a matter of extraordinary intellect, but rather of practical wisdom. However, practical wisdom applied at the opportune moment, coupled with fortitude and perseverance, possesses the power to reshape history. This is Ted Nelson's lasting legacy, not the 50 million hours preserved, not the 2 Emmy Awards received, not the global enterprise that continues to bear his name. His true legacy is the irrefutable evidence that a single individual, armed with a sound concept and the unwavering resolve to bring it to fruition, can effect profound change. That legacy endures with every activation of a stud welding gun by a welder. Each time a vessel is completed with greater celerity than previous methodologies allowed, and whenever an individual scrutinizes an inefficient procedure and poses the question, surely there exists a more effective approach. Ted Nelson posed that very question in 1941. His response played a pivotal role in securing victory. What inquiries are you posing today? And more critically, when the authorities deem your idea unfeasible, when the administrators instruct you to adhere to protocol, when the doubters disparage your concept, will you possess the courage to prove them mistaken? The Chronicle of Innovation suggests that occasionally the most impactful action one can take is to disregard the pronouncements of experts. Place your trust in your own observations and construct the solution you are confident will succeed. Ted Nelson embodied this principle precisely. 80 years hence, welders across the globe continue to utilize his invention daily. And somewhere, perhaps in a modest garage or workshop, the next Ted Nelson is diligently sketching an idea that many proclaim will never materialize. But they will be incorrect, for the most transformative innovations do not arise from mere adherence to established procedures. They originate from individuals who perceive a deficiency, understand its remedy, and steadfastly refuse to accept a negative outcome.